Okay, so let's jump in. We've got this really interesting set of sources today, and they're all focused on something called reasoning LLMs.
Mm-hmm. Large language models, but a specific type.
Right. Yeah, most people have heard of LLMs, but these ones, they're specifically designed with ways to try and reason through problems.
Yeah, to sort of think it through rather than just giving a quick answer, especially for complex stuff.
And the sources say a big part of that is generating what they call a chain of thought.
Right, like laying out the steps, showing their work almost.
Exactly. The idea is this helps them tackle difficult questions more accurately.
And it has led to some pretty amazing results on benchmarks, those standardized tests.
Oh, definitely. Super impressive scores, which, has fueled a lot of talk. Maybe AGI, artificial general intelligence, is closer than we thought.
But that's where our sources pump the brakes a little.
Okay.
While those benchmark scores are impressive, the material we looked at really emphasizes that this idea of imminent AGI, well, it is far from the truth.
So a reality check, basically.
A big one. There's a key research paper highlighted that digs into some pretty significant limitations they still have.
And this research, it didn't just use the standard test, did it? They used puzzles.
Yeah, puzzles. Which sounds maybe a bit simple, but it was actually a very clever move, according to the sources.
Why puzzles?
Well, it helps get around this problem called data contamination.
Ah, right. The idea that maybe the models have already seen the test questions or something really similar in their training data.
Exactly. With the massive data sets these things are trained on, it's a real risk for standard benchmarks. Puzzles, especially new ones you can tweak the difficulty of, give a cleaner test.
So you can see if they can actually reason, not just remember patterns.
Precisely. Can they figure something out fresh?
Okay, so what did the puzzles show? Did the reasoning models ace them?
Well, interestingly, no. On the easier puzzles, these reasoning models, they did no better than simpler models, sometimes even a bit worse.
Huh. That's counterintuitive. You'd think the thinking step would help even then.
You would. And then, as the puzzles got harder,
Let me guess, they struggled.
they didn't just struggle. The sources say their performance essentially collapsed, completely fell apart on high complexity.
Wow. So the reasoning mechanism didn't scale with the difficulty.
Not only that, but the research found something else fascinating. Even though they could generate longer chains of thought, put in more effort,
Yeah.
they actually tended to do the opposite. As the problems got harder, their reasoning steps got shorter, less thorough.
Like they got lazy.
Sort of, almost like they gave up when it got really tough, instead of trying harder. The sources also mention overthinking,
Also.
getting stuck on wrong paths, even if they'd actually found the right answer earlier in their thought process, they just couldn't recognize it and move on.
Okay, that's messy. But what was the most striking finding?
For me, reading the sources, it was the instruction following bit, or rather the lack of it.
What happened there?
The researchers literally gave the model the correct algorithm, the step-by-step instructions to solve a puzzle. Think, like a simple version of Tower of Hanoi.
Okay, straightforward instructions.
You'd think,
Yeah.
but the model just couldn't use it effectively. It still failed at roughly the same complexity level as when it didn't have the algorithm.
It couldn't follow the recipe, even when it was handed the cookbook.
Pretty much. It suggests it wasn't really understanding or executing the logical steps provided.
So let's tie this together. What's the main takeaway for, someone listening?
Well, it means that despite those flashy benchmark results, which might be a bit skewed anyway by that data contamination issue, these models aren't quite the generalized reasoners we might imagine.
They're good at patterns, maybe stuff similar to what they've seen.
Exactly. But truly novel problems, complex reasoning, even following simple, explicit instructions, they struggle. The sources are pretty clear. These models need significant improvements before we begin fantasizing about a future with superintelligence.
So that AGI talk, still quite a way off based on this.
It seems that way. True reasoning, the kind that can flexibly apply logic to new situations, that's still a huge hurdle, especially if they can't even reliably use a simple algorithm you give them.
It really makes you think, doesn't it? If a model gets the exact steps needed and still fails,
Yeah.
is it thinking like we understand it?
Or is it just incredibly sophisticated pattern matching based on everything it's ingested?
Yeah. What would genuine understanding, genuine application of a new rule actually look like in a machine? That's definitely something to ponder.